I don't know if you know she's still alive. Okay. So your bond's broken R 2 times, what was that for H? 436. And plus 2 for the double bonded oxygen. I'm sorry, 1 of that one is 499. Minus 2, I'm sorry, 4. So that 4 times 464. Mental math it up. You should have gotten negative 45.
Wait, why is it 4?
Because there's 1, 2, and then 1, 2. Mental math for this one, the values were somewhat close on this one. It was about a spread of 40 kilojoules. So you just have to be a little bit more careful with your mental math, not too much estimation. All right, 27. I'm just going to go through some method stuff. If you guys don't, if you're good with the quiz and you don't want to listen for your unit review or start FRQ 4 and 5, if you're trying to use your class time wisely, okay? 27, determine the delta H of the reaction above if methane or methanol were formed from the methanol liquid was formed from the reaction instead of methanol gas. So this one is harder because you have to read between the lines on why in the world they gave you that last sentence. Last sentence says delta H of vaporization. What does that mean?
It's vaporizing.
So going from what state to what state? Right. So methanol liquid is going to methanol gas. So they're saying this in a sentence versus writing this out. The H of vaporization for methanol is 37 kilojoules per mole. And that's endothermic process because that requires energy to vaporize. In the previous equation, they gave you CO gas plus 2H2 gas yields CH3OH gas at negative 91 kilojoules per mole. Alright, so their question is, what would be the delta H of reaction if instead of forming liquid, I'm sorry, yeah, this is the gas. I'm sorry, you would form a liquid instead of this gas right here. So technically what they're asking is for you to do the same thing, CO gas plus 2 H's, yield the liquid version of this. So what were they kind of asking you to do? Hess's law. So they said the second BCE in word form versus writing it out. So that's why it was hard, because you had to read between odds. I'm like, oh, I should probably write this as a BCE. And then, oh, how do I get the known product to be liquid instead of gas? Well, what do I want to do to this second equation? Flip it, because when you flip it, the gas on this side will cancel with the gas that's on this side. So I'm going to do a negative 1 thing. Say I'm flipping that, which makes this now a negative 37, right? So that negative 37, and this inversion of the BCE allows the gases to cancel out, leaving the liquid over here. You have your given, if that's asked for, and then you add that up to be negative 120 something. Negative 128. All right, anything before 26 and 27? Yeah.
7.
6 and 7?
7 and 6.
Energy given off when a substance condenses. So heated vaporization is whenever something vaporizes, right? But that energy is given off. That same energy is given off when it condenses. It's the same energy, it's just positive or negative. So technically, like if you wanted an exact answer for that, would be heat of condensation would be the better way to say it. But when they state the heat is given off, it's the same quantity of kilojoules, it's just given off as a negative value versus a positive value. And then 6, substance is taken in, so endothermic when a substance melts. Well, that's just the opposite of fusion, because fusion is melting, and it would say like heat of solidification or heat of freezing to actually be the freezing process. But that one actually is the heat is taken in when a substance melts. That's right. E is right. 6 is E. All right, between 7 and 26, Krista.
Number 19.
19. Okay, this one involves the volume change, and what's so special about water when it freezes? Comes with volume. Anybody? It expands. So going from, are we freezing? What are we doing? Yeah, we're freezing. Going from liquid to solid. The volume of water will be greater than 0. The volume change will be greater than 0 because water expands when it freezes, and that's why ice floats. And a little known fact, some of us know, some of us don't. The entropy is going from liquid to solid. What happens to entropy? It decreases, so entropy will be negative, going down negative, so delta S will be less than 0. And then you know from the mere fact that liquids move faster than solids, so themselves, they have more kinetic energy inherently within their molecules. Going from a high kinetic energy system to a low kinetic energy system, what would happen to delta H then? It's releasing it, so it's negative, so it's less than 0. Oh, which answer that is? That is 20 or 19 is B. Yeah. So positive, negative, negative. Another one? Yep. Yeah.
Number 23,
See, these are like those ones where you have to fight in your mind with the math. What is... Okay. We are given this reaction's only spontaneous above 550 degrees Celsius. So spontaneous means delta G is a what value? Negative value. So above 550 degrees Celsius, it is a negative delta G. So at 400, what would be true about delta G? It's a positive delta G. So that's just kind of like my first thought process. So what is true for 400? Well, you know you can cancel everything except for what? All right, A and E are the only options at this point because they're the only ones with a positive, non-spontaneous, non-thermodynamically variable delta G. So then you have to figure out you can make the math work. You can look above and see that you have, is that balanced? Yeah. 1.5 moles of gas going to 1 mole of gas. So your thoughts might be, oh, well, the entropy is decreasing just by looking at the equation. But let's just see if we can make the math work. Because you have to have delta G is equal to delta H minus T delta S. So this has to be positive. What ways make it positive? At 400, but when you increase, so making this variable, this whole, toss thing you guys are saying, when it's 550, it's large enough to make this negative. So it's a thought process. This needs to be, when it's a 500 version, it's so large, it's going to say something minus a large number to be negative. So what did you guys say for this one? Positive, positive. Positive, positive, positive? Yeah, those ones. It was A? Mm-hmm. Yeah, okay. Because for this to be, if this was a small number, you take a positive number minus a small positive number, it's still going to be a positive number. And that's what we see when we're at the 400 version. But, if this is a large positive number, because the large value being the T here, a positive number minus an even larger positive number is going to bring it down to the negative region, which would be the spontaneous one. So you just have to think about the size and the values, the negative positive values of that toss right there. Yeah.
So it has nothing to do with whether S is negative or positive, it's just whether it's large or small.
It does deal if it's positive or negative or positive, because if this was a large negative value,
it'd be just adding.
And that would be a lot, but a large negative value would be adding, it would be positive still.
Yeah.
So I see your point there.
But I think the thing is though, even if it was 550, you'd still be adding a large.
Yeah, but your question really lies between the two values. Like when you put it that even make that even larger number, does it yield a negative value? And that's why I think you have to have the minus symbol there. Because, it has to be a truly minus, not like a minus, because that would be a positive and that would not be a negative value. That's where the difference lies. Okay. All right, what was another one? One more maybe? Solid sulfur is burned. Oh, this is the math one. Okay. Oh, my math work. 47. Oh, this is not that much math. Okay. Knowing that, we have the heat released by burning 1 kilogram of sulfur is captured by 250 liters of water. Assuming all the energy produced is used to heat the water, so all the energy goes to the cube of water. That starts out at 25, so Ti is 25. What will be the final temperature? Okay, so essentially you want to solve for delta T here, and then just backtrack to the T finals. We're given delta H of reaction to be negative 296 kilojoules per mole. So this is a conversion factor because it's mole of sulfur. Yeah? There's got a coefficient of 1. So it's 1 mole of sulfur. So if you have 1 kilogram of sulfur, you want to go to moles first. That is 32.06. So 1 kilogram is 1,000 grams. Sulfur, 1 mole of sulfur, 32.06 grams. Sulfur, 1 mole of sulfur will put out 296 kilojoules per mole. And I'm going to go to joules because my cubicles and cat formula has joules in it, not kilojoules. So 1 kilojoule, 1,000 joules. Okay, estimate. Not fun, but possible. I said, I didn't do this just yet. So I said, if this was 100, 30 going to 100 3 times. So that's 1,630 times, right? So 30 times 300 is about 9,000, because you add your zeros, and 3 times 3 is 9. So 9,000 times 1,000 is 9.00, or 9.0 times 10 to the 6 joules. Okay, got that part. Your mass of water it was 250 liters, so, right. So the mass is 2.50 times 10 to the 5th grams, because you take your 250 liters is that many milliliters, and that many grams, of course, as well, because the density of water is 1. So I just took my decimal back and said 2.5 times 10 to the 5th grams. Specific heat of water, 4.84 joules per gram C. Specific temperature change, I don't know. And I like to do scientific notation on this because my math is a little easier. So, which math step did I do next? I think I divided, and then I divided by this one, and then I divided by that one. So I'm going to run this up to 1.0 times 10 to the 7th and see how close we are, because that's easier to do than 9. Divided by 2.50 times 10 to the 5th is what? These go away, almost, right? So it's 10 to the 2nd. This would be, so 1 divided by 2.5 is actually 0.25, right? Because it's 1/4 of that. Okay, so then how would you change this? 25. I'm just going to go 25 because that's easier for me. Because I can just move my decimal over. Is equal to 4 point blah blah blah. Okay, so 25 divided by 4. 25 divided by 4 is about 6. About 6. I'm going to see how close our estimation powers are. So about 6. So that's delta T. What is the final value of temperature if our temperature started at 25? 25 plus 6, about 31. Closest one was 35. Okay. Mine is actually a lot closer when I did it, but that's cool. We can estimate, and those values are very, very far apart. That was a good math one. All right. Take a minute, look at your stuff. If you have another question, I'm good to answer. thought about going to your FRQs right now, but I think you're going to your quiz first. Yeah. Because FRQs, I want everybody. Well, you want to go FRQs first or quiz first? Quiz.
I don't know.
I'm also going to. We'll do quiz first. When you're ready, I have about 20 minutes. It's on Socrative, so if you want a computer, sit at a computer because you want some space. Computers are yours. Otherwise, it's on your phone. And you will have paper probably with you to write down some work. You guys know how to get to Socrative. You Google Socrative. Then you hit student, and the Enlo, just the word Enlo is the login.